The last thing we're going to do, or excuse me, not the last thing, the third thing we're going to do is talk about change of base. We'll talk about how it works in a different video if you're concerned about what the proof is. So let's say that you have a log with a certain base of a certain number, but you can't get a common base. So for example, like, you know how we could do like 3 squared is the same, like you can write it, hold on, let me try again. Let's say that we have 3 to the x equals 27, that's better. We could write both of these as a base of 3 because 3 to the first is 3 and 3 to the third is 27. So that's really not a problem when the base is a 3 and that, like, if this was a 3 and this was a 27. But what if that's a 3 and that's a, like, I don't know, 100? There's no special number that you can raise 3 to get to 100, like 3 to the third, 3 to the fourth, 3 to the fifth. It misses it. So we can use what's called the change of base formula, where we write them both as a common base, and we put this one on the top of that common base and this one on the bottom. Now, usually that common base, we use a 10 because that's what every calculator can do. So like this calculator, for example, is a free one, a free download. And that log button, if I go here and I try to do log base, I can't because I didn't pay for my calculator, so the free one. But this log has a base of 10. So I can use my change of base now to be able to type it on any common calculator. So let's run something, an old one, where you can get a common base, okay? So we don't need the change of base formula. So this one, 9 to the unknown power is 243. Well, that's going to be 3 to the second power, and that's going to be 3 to the fifth power. Double checking. There we go. And this x drops down right here. Okay, so that's old from previous lessons. And the 3's, you know, we can just set their exponents equal, and we get x equals 5/2. So that's not too bad. We've learned how to do that. This has a common base of 3, so it's very, very possible. But let's say that we come over here and we're like, 9 raised to what power is 400? Well, I could get this down to a base of 3, but this can't be written as a base of 3. So this idea of getting a common base is no longer exists here. So again, let's say you're stuck at home and you only have one of these calculators and you can't use that log base thing. You have to go ahead and change the base. So remember, we're going to make the base into a 10 using change of base. So you draw a fraction bar and you put log base 10 and log base 10 on the top and the bottom. Of that log base 10, we're going to put the 400 here and the 9 here. Now remember, you don't really need that 10, it's implied. So we changed the base from a 9, because this calculator, most calculators cannot do that, to a base of 10, which our calculator can do. So watch my calculator when you do log of 400. I'm going to get out of that. I'm going to divide by log of 9. There it is. What do they want us to round to? Nearest hundredth. That's 2 decimal spots. So 2.73. And now we don't have to be like, oh no, because we're good to go. So just to prove what we did, if you do 9 to the 2.73 power, 9 to the 2.73 power, you get pretty close to 400. And so I know I did it right. Remember, we had to round. So 2.73 is our answer, and we can do that with any calculator, even a normal cell phone calculator. Now, again, this one is old school because we can get 25 and 125 into a common base of 5. So we can do 5 squared on this side and 5 to the negative third on this side. We can get 2x equals negative 3, and x is negative 3/2. Because that's old, that's the old way of doing it. We can get a common base of 5. But let's say you're like, you know what, Miss Langella, I always hated that. Can I do common base here? Absolutely. You do log base 10 of 1 over 125, log base 10 of 25, and sure enough, your calculator will give you the answer. 1 over 125 divided by log, and what am I doing? 25. And there's the negative 1.5 as your answer. Celebrate. Or I really like change of base. I counted once. It's the same number of buttons to do change of base than it is to like hit this math button and to find that on the in the class. And plus, this way you can use any calculator. Let's try one more time. So 15 to what power is 9? Well, I don't have a common base. So I'm going to change to my common base of 10, put the 9 on the top, and the 15 on the bottom. They're in base 10. So let's see, let's exit out of this. Log 9 divided by log 15. And so I guess my exponent would be 0.81. So if you do 15 to the 0.81, there it is. That gives you about 9. And that's how you use the change of base.